Hello, and welcome to another session of GMAT Inequalities with GMAT by examples. As usual, we will learn a concept and solve some examples to apply the concept. As you can see from the examples on the screen, many times GMAT can test you on the relationship between x, 1 by x squared, 1 by x squared, x cubed, and so on. So the question is, how do we approach such questions? Is there a specific approach or framework to attack these questions? The answer is yes. As always, if you have questions about the video or any feedback, please contact us at contact@gmatbyexample.com. Please do not forget to like the video if you like it and subscribe to our channel. When a comparison needs to be drawn amongst the terms like x square, 1 by x, 1 by x square, you should, I've drawn a number line here, and you should immediately think of ranges which is minus 1 to 0, 0 to 1, and 1 to infinity. Even if you don't understand everything that is part of this tutorial, if there is one thing you should remember is these ranges. You can always pick values within these ranges to solve these questions. If you can remember the rest of the approach, it would be even better. Let's try to understand why these ranges are important. Let's take x and 1 by x for example. If I ask you how do you compare these two, the instinctive thing to say is that hey, x will be greater than 1 by x, which is true in this range, right? So 2 then 1 by 2, when x is greater than 1, x is greater than 1 by x. But between here and here, let's take example 0.5. What happens to x is 0.5 and 1 by x is 2. So in this, x is less than 1 by x, right? Similarly, here it is again greater, and here it is again smaller. So the real challenge is, what is the relationship between x, 1 by x square, x cube, 1 by x square, x to the power 4, etc. Let's find out with the help of a table, which is minus infinity to minus 1, between minus 1 and 0, 0 and 1, and x greater than 1. And then here we, on the left hand side, on the in the rows, we have x square, x cube, x4, 1 by x, and 1 by x square. We will take the values between each of these ranges and see how the values shape up, and finally we will write down what the final comparison is. So let's see x. Let's assume x to be minus 2. It falls in the range x is minus 1. What are the corresponding values? So let's see. X square would be 4. X cube would be minus 8. X4 would be 16. 1 by x would be minus 0.5. And 1 by x square would be 0.25. So what would be the comparison here? Obviously, x to the power of 4 will be greater than x square, will be greater than 1 by x square. These are all positive. And the next number in line would be minus 0.5. As you can see in the negative numbers, this is the greatest. Then comes x, then comes minus x. So it's greater than 1 by x, which is greater than x, which is greater than x cube. So that's the relationship between for x less than minus 1. Now let's take a similar example for the range minus 1 and 0. Let's take x as minus 0.5. X square would be 0.25, obviously a positive number. X cube would be minus 0.125. X to the power of 4 would be 0.0625. 1 by x would be minus 2. 1 by x square would be, so here what is the greatest number? Obviously 1 by x square. So the comparison goes somewhere around 1 by x square is greater than, what is the next positive number? X square is greater than x to the power of 4. So these are the positive numbers in the line. And now let's look at the negative numbers. The next we have x cube. X to the power of 4 is greater than x cube is greater than x. So similarly for 0 and 1 we have a very entirely different range. So 1 by x square, and for the range x is greater than 1, let's take x equal to 2. We have the most intuitive 4 greater than x cube, greater than x square, greater than x, greater than 1 by x, greater than 1 by x square. So the important thing to remember is that once you have derived these relations don't change. They are applicable to all values of x for these ranges. So if you can remember these comparisons, then you don't have to derive them in the exam. It takes time. It's not easy to remember them. I agree. But if you practice, they start becoming more intuitive. For example, for x is less than minus 1, higher even powers of x are higher, which we know because it is a negative number greater than 1, so higher even powers are higher positive numbers. So it is intuitive that x4 would be greater than x square and x cube would be less than them because x cube would be a negative. So finally we have something like this. Next, we will solve the questions that you first saw in the start of the video. Three choices. First, you can remember with practice all of these relationships. Number two, you can quickly derive them because it wasn't too hard to derive them, as you can see from the table. Or third, if you don't have enough time, you can always focus on these ranges, pick the values of these ranges to answer the questions. And the question asks in terms of the less than signs. So let's kind of rewrite so it is easier to compare. So 1 rewritten as x square is greater than x cube is greater than x. The question asks which of the following could be correct. So any of these ranges are fair game, and even if the relationship is true in one of the ranges, then that choice qualifies as a possible choice. X square is greater than x cube is greater than x. Where is this applicable? Look at this range, minus 1 and 0, x square is greater than x cube is greater than x. So in minus 1 to 0, this one is applicable. So this could be correct, hence this is an okay choice. Let's take choice number 2, x less than minus 1. It looks promising. X to the power of 4 is greater than x square, but x is greater than x cube. So this is not the case. This is definitely not the case because x square is greater than x4. This is also not the case because x square is greater than x to the power of 4. And here x to the power of 4 is greater than x cube is greater than x square. So that is also not the case. So this relationship can never exist. Let's take number 3, x to the power of 4 greater than x square greater than x to the power of 3. This relationship does exist for x to the x less than minus 1. It could exist somewhere else also, but this is enough to answer the question as this relationship could be true. The fourth one is, again, if you look at x less than minus 1, you'll see x to the power of 4 is greater than x square is greater than x and is greater than x cube. So within this range, this relationship does exist. So this also could be true. Hence your applicable choices are 1, 3 and 4, which means your answer is D. Okay, so this is question number 2 that we saw at the start of the video. The question asks, is x square greater than 1 by x? And then gives us a couple of conditions. So we'll use the same framework. If we know these ranges and what are the relations in each of these ranges, where is x square greater than 1 by x true? Let's look at this range. X square is greater than 1 by x. So it's true in this range. In minus 1 to 0, x square is greater than 1 by x. So it's also true in this range. It is not true in this range. And again, it is true in this range. So the question is asking, is x in any of these three ranges? That's the real question. So now let's take statement A. We are given x square is greater than x. So x square is greater than x in this range. So we are given that x could be in this range. X square is greater than x is also in this range. So we are given that x can be in this range. Here x square is actually less than. So we are given that x is definitely not in this range. And then again x can be in this range also. So as you can see, the ranges match perfectly. So what we are given is x square is greater than x. Hence, x has to be in one of these three ranges, which is exactly the three ranges that x square is greater than 1 by x in. Hence, this is sufficient. Let's take B. We are given 1 is greater than 1 by x. When is this possible? Again, let's go back to ranges. When x is less than minus 1, is 1 greater than 1 by x? Obviously, because x is negative and 1 will be greater than a negative number. Same thing here, because x is still negative. In this range, is 1 greater than 1 by x? The answer is no, because x, for example, take x as 0.5, 1 by 0.5 will be 2. So 1 by x will be greater than 1. And in this particular range, is 1 greater than 1 by x? The answer is yes. So again, we are given that x satisfies the condition 1 is greater than 1 by x, which means x has to be in one of these three ranges, which is exactly the range the question is asking for. So even statement B is sufficient. That's all we had to do for this question, rather than trying to solve or simplify the inequalities in any other way. I hope you liked the video. I hope you understand the framework and you can apply it in more questions. And please do not forget to subscribe to our channel for